Okay, so just repeating, the Arraylist is a class that manages a sequence of objects. It can grow and shrink as needed, which is nice. And then things like inserting and removing things in the Arraylist are a lot easier than you would see in an array. It's also a generic class. This was added to Java, I don't know, relatively recently. And what computer science call it is a generic. And what a generic means is a lot of people would implement maybe an array that stores integers, or an array list that stores integers. Another would be an array that stores strings. The only thing really different is the data type you're storing, but the whole process of adding and removing and inserting are always the same. And in C++, they realized this, and they added this this idea of a template class. It was pretty innovative at the time, and it's still pretty innovative. So all the other languages had to figure out a way to do the same thing. And so this is Java's version of generics. Basically, when you declare an array list, you have to tell it the type of thing you're going to be storing. Now, the original implementation in Java was pretty lame, where you could really just store objects, and it didn't really check to see what kind of objects the array list is storing. But now they've added the data type in here. So here's an array list of strings called names, and here's the declaration. The only thing different about the syntax is you have this weird angle bracket thing going on. And all you're doing there in the angle bracket is just saying, hey, this is an array list of strings. So you're specifying the data type of the things you're going to be storing in the array list. But realize that can be anything. That could be strings, that could be shapes, that could be rectangles, anything. That's an object you can do this way. And then when it comes to adding names, it's really simple. You just say the name of the array list, a dot, and then add, and then you just put in parentheses the thing you want to add to the list. So very convenient. So then it begs the question, well, why would you ever want to use an array if you have this array list? It seems so much simpler to use. Well, there's a couple things that are bad about array lists. You can also ask an array list its size. Now, if you remember in our arrays, we could ask the array how many things were in the arrays. You would say array.length with no open and closing bracket. So this is what really bugs me about Java is an array list, to get the number of things you get the size. It's a method. If you're an array, you ask for length. Well, length and size mean the same thing, and trying to remember which one goes which is really quite awful. So I don't know that it's purposeful that they use two different words for the exact same thing, but I guess length is a property. It's not a method, and size is a method, but that's all I can figure out. So when you want to add an element to an array list, say our list after the first two lines of code, it's right here. Emily and Bob are inside this array list of strings, and now we're adding Cindy. Well, there's the array list, doesn't change position. This automatically increases its size by 1. So you don't have to do that. With an array, if you had something with 2 things in it and you need to make it 3 things, you'd have to allocate another array that was 1 bigger and then just copy over the ones you need. So very cumbersome if you were in an array. But in an array list, you do this all the time. You can add stuff, you can remove stuff, and it keeps track of all that for you. So that's how you add an element to an array. Now, instead of using the brackets, the square brackets and a number, just say which one you want. In this case, we have a get method to do that. Just like in arrays, the index that you use to get to a certain element in the array starts at 0. So if you want to get the third element in this name array, you can go and just say names.get. And this time we're using parentheses, not square brackets, because get is a method. Square brackets is a type of operator, so it's different. All right. Now, also just like arrays, if you try to index outside of the array, say you ask for the fourth thing in the array by putting the number 3 in there, you'll get a bug happening. Here you say array.size or names.size. That tells you the array list right now maybe it's 3. And you store that in the I, and then you go out and try to get that third thing. It's going to blow up because the index 3 is not the third thing. The index 3 is the fourth thing, and there is no fourth thing in the array list. So you just like with arrays, you can't take the size or the length and use that as an index. Because remember, both for arrays and array lists, they both start at 0 for their index. So if you try to put the size in there directly, you're going to go one past the end of the array or array list. So you get a bounds error. Everybody get that? And move forward. Okay. Now, commensurate with the get method, there's also a set method. So you say names.set, and this takes 2 arguments. The first argument is the index you want to store it at. Say we want to replace Emily with Carolyn. You can do that, calling the set method. So set and get are like the accessor and mutators for array lists. Say you want to remove an element. Simple. You say names.remove, and you pass in the index you want to remove. That's simple enough. So if we're going to transform this a little bit, so we put in Emily, we put in Bob, we put in Cindy, and then we set 2, which is Cindy's slot, to Carolyn. So right here, so now we have Emily, Bob, and Carolyn, and then we add Ann to the list. But notice this type of add, we're specifying where to add it. This is like an insertion. So we're saying, right before index 1, that's the second thing in the list, I want to insert Ann into the list. So now Ann gets inserted right here. And the array list is smart about that. It says, oh, this one's being inserted in between, so I'm going to scoot the other ones down and stick Ann in the middle there. You can't do that with an array automatically, but with an array list, that happens automatically for you. So that's how you go about inserting something. If you just want to add it to the end of the list, you just say add. If you want to insert it somewhere, you provide the index where you want this thing to go in the list, and then you move on. And then if you remove something at index 1, now everything is scooted back up and it's back to where pretty much it started. Except for Cindy, I guess. So again, the syntax is really good. The way you go about adding, inserting, and deleting stuff is really straightforward. Okay, so the hardest part about an array list, I think, is just specifying the constructing it, I guess. So here's how the constructor looks. That's kind of strange. We have a new symbol. We've got to understand what it means. Adding elements is trivial. If you print out an array, it's really interesting, or an array list. It prints out each item in the array. You don't have to write a method for doing that. It will just show you every single token in the array. I'm not sure what it does when they're... I guess the thing it does is it takes whatever's there and calls the toString method on it and puts those in brackets. So if your object has a toString method, and again in Java, every object has a toString method, even though you didn't write one, it will print out those two string methods for each element in the array. If you want to insert an element in the array, you can do that like we just saw, removing it at a specific position. And then if you want to change Bob's name to Bill, you can do that by calling set. So we have set, remove, add, two versions of add, one to insert and one to add to the end. I kind of like the way it prints this out. You can just quickly look at your array inside your code and print it out to a report. Makes it simple. Other things that you'll see with an array list is the get method. And that gets an object from the array at position I. And then if you want to get the last element, notice you can do that just by taking the size and subtracting one from it. If you do the size directly, again, we get an error there. You'll go outside the bounds of the array. And here's just a small program snippet where you have this array of integers. Notice it's a capital I integer, so this is the integer object. It's not a fundamental data type. So you call it squares, you create the array list, and then you can just go through it and add the squares to the array, and that will add them starting at position or index 0 and going on from there. How many will it do? It will do 10 from 0 to 9. Right. So here's the syntax diagram. The first line is how to construct an array list. We call the new method on the array list passing in the data type. To access something in an array list, you call the get method, or if you want to change an array list member, then you call the set method. When you start out an array list, it starts out with no elements, so it exists in memory, but it doesn't have anything in it. The array list is empty. So syntactically, the only thing that's really that much different is the way you construct it. After that, it looks pretty easy to understand. Okay, so here they have an extended example of an array list, but we're going to do an assignment that will tell us the same information with stuff that's a little bit more compelling. But we'll do that in a moment. So let's compare and contrast. We have an array of 10 strings and an array list of 10 strings. How would they differ? Well, one you would call new string and pass in 10. That's for a regular array, just a standard plain vanilla array. If you want an array list of strings, notice how the syntax changes. You say new, but this time you use the identifier array list, and then you put in angle brackets the type you want. And then the other weird thing is, and you also put this open and close parenthesis because it's a constructor. Okay, so really different on how it declares the two different data types. So moving on, everybody get this? Hopefully you're taking notes. I don't see a lot of people taking notes, so this gets pretty gnarly. Okay, so here's our example. We have a list of names, an array list of names. We add A, then we add B at position 0 or index 0, so that would make it BA, I'm guessing, and then you add C, so that gets added to the end, BAC. And then you remove the first one, which is actually the second one. So you get B and C. Let's see if that's what we got. Yeah. Names contains the strings B and C at position 0 and 1. Okay, so we're going to stop there, and we're going to take a look at adding an array to our shapes example. So if you can get your shapes project up, I can show you how to set this up. Now up to this point you should have already turned in your shaped example. So if you haven't, make a copy of it, make a copy of the whole project and move it off to the side, because we're going to be further enhancing our shapes library. Just go outside of NetBeans and just grab the whole folder, make a copy of it, and then go back into NetBeans. Yeah, I do. I'd like to see it before we make these changes. So basically your house picture, that should be what you turn in. So turn in your house picture without these changes in it, okay? With the equilateral triangle. Make sure that gets tested. So far in here we have this drawing component, right? And what I'd like you to do is we're going to create an array of shapes. And what we'll do is for each shape in our house picture, we're going to put it into an array rather than just creating a separate variable. Right now what we're doing is we're creating a separate variable. This one's called house body. Here's the door. Here's the roof. Instead of making just discrete, separate objects in our picture, we want to put all the parts to our picture into an array and see how we would go about drawing that after that point. So this is when we're drawing it. So I'm trying to think about where's the best place to put this. I guess we'll put it here. So, and we're going to try this two different ways. So first we're going to try it as an array. And the things that we're going to be storing in it are shape 2Ds, which is kind of interesting. Let's see if we can make this work. So we say, So we're going to create an array of shape 2Ds, and we'll call this one So here's our house picture. It's going to be, we'll just call it house picture array equals new and we want to put an index here, or a size here, that matches up with the things in our class. So we have to count them up because we need to know this ahead of time, because this is an array. So we have the rectangle for the house, the rectangle for the door, the circle for the door, the roof, the sun, 4 parts to the window, perhaps 4 squares. That gets us up to 9. And then the tree, which is made up of 3 things, so 12, I guess, might be the number you would use. Here I only have 2 parts of the, or 3 parts to the picture, so I'm just going to put a size 3 there for now. Remember, that's temporary. see why it's complaining. Oh, okay. I forgot to put the brackets here. So you have to tell the compiler, hey, this is going to be an array of shape2Ds, and the way you declare it is like that. So we create this new rectangle. We set the parameters for it. And notice here we draw it. I'm going to comment that out for now. And then I'm just going to add this rectangle to our list, or to our array. So we would say house picture and we'll pass in the first index, which would be 0. And here we'll set it to house body. So with an array list, you would say set. But here, since it's just a plain vanilla array, we just assign the first shape into our house picture array right there. Next, we create the door. The door is pretty easy. It's just a rectangle. So we can say a house. I forgot to draw it, so we'll get to drawing it in a second. So our first thing in our array is going to be the house body. The second thing in our array is going to be the door. Notice it has an array index of 1. Finally, we have the isosceles triangle. And again, we're going to hold off on drawing it. So this is the third thing in our array, and this is going to be our isosceles triangle, which will act as our roof. And note too here, I'm not calling draw yet. I'm just adding things to our array. So I'm getting rid of draw. Now, one of the most powerful things about the Java language is the ability for you to create a list of generic things like a shape2D and have them draw themselves. And the weird part is you don't have to tell the compiler explicitly the shape you want to draw, because we have an array of shape2Ds which you can't draw, right? Because shape2D doesn't have a shape. There's like three main concepts in object-oriented programming that are the most important. One is that you're encapsulating. It's called encapsulation, where you put the data and the methods that work on the data in one package. We've been doing that since day one. The next one is inheritance, right? Where we have this parent shape2D and it inherits all those attributes and methods from shape2D down into its children. The last object-oriented principle that's the most powerful, I think, is this idea of polymorphism. So let me write that on the board. Yes, I was alive when this first came out, and I got to kind of see all the discussions about it. But what does polymorphism mean? Well, poly means what? What was that? Many? Okay. Like polygon has many sides. Morphisms? Shape. So many shapes. And that's why I use this shaping, or the shape library, because we're talking about shapes, actually talking about shapes. Okay? And what we want to do is we know that all our shapes have a draw method. Do we have to know what shape it is? Not really. All we have to do is tell the shape to draw itself. So when you call draw on a shape, it's going to go figure out what kind of shape it is by itself and say, oh, here's my draw method, I'll draw it in this location. So let's try it. We would say, well, how many things are in our array? So we put in a for loop. We have our house picture array, and we can ask the house picture array to tell us the length of it. And that's a property. Close this so we can see. And then we just say I++, just like we do with most for loops. Now, if you forget how to do for loops, that's from chapter 6, and we have you can go back and take a look at those videos on arrays, or actually on loops, to do that. Just a quick overview though is, first you initialize the control variable, and that happens only once up at the top of the loop. Next you make sure that I is less than the length of the array, and that's at the top of every loop iteration. And once that becomes false, then you stop doing the loop, and then at the bottom of the loop you do this last thing. You add 1 to I. So now we can just say this, house picture sub I. Okay, so we're going to index through each item in our list, and we're going to tell it to draw itself. And this is a big deal. You didn't ever used to be able to do this. Is you would say we add another shape to our library. Maybe it's the equilateral triangle. As long as it's derived from shape 2D, we can still draw it. So at this point, when you write the code, you don't have to ask the question, okay, what kind of shape are you? Oh, you're square? Okay, square draw. You don't have to do that. Here you can just say, hey, I know all of these things in my picture are shape 2Ds, and every shape 2D has a draw method. Because if you remember back in shape 2D, we made sure that the draw method had to be implemented by the children. Let's go back and look at our shape 2D. See, right here we said, okay, shape 2Ds will have a draw method, but at the shape 2D level, we don't know what shape it is, so we can't really draw it. All we can say is, okay, any kind of child class that gets derived from shape 2D has to provide a draw method. If it doesn't, then the compiler will not compile the code. So by making the draw method abstract, meaning we're going to define it later, this allows us to draw our shapes, even though if we look at shape 2D here, there's no implementation to the draw method. What it's going to do is it's going to go to the children and find the right one for the children and run that one. And that's all because we made a draw method common to all the shapes, and they know how to draw themselves. So it's really a different approach. Let's go back to our example here. It's complaining here. Oh, it says use an enhanced loop. Okay, I'll have to look at that. This is kind of old school, I guess. But it still works, I think. So if we run it this time, my shapes aren't really lined up, but you see I have my door, I have my roof, and I have my rectangle. So I'll spend some time getting these lined up, but you can see now that we have this array, you can just put any shape you want into the array, whatever order, and then just tell them to draw themselves. And you don't have to know what type they are. They know how, a rectangle knows how to draw itself. A triangle knows how to draw itself. And so it does. Up at the driving level, when you have our loop, we don't really care how it goes about drawing it. We just care that it's drawing it. And this is what makes object-oriented programming powerful, is this concept here, polymorphism. The ability to call methods on objects where you don't know exactly what type of objects they are. All we know is that they're shapes, and they know how to draw themselves. That's pretty weird. So what I'd like you to do is to go and make these changes to your house picture and create an array of shapes. And see if you can get your house picture to draw just like it did before. But this time, in your drawing component, we're going to create an array. We're going to stuff each one of the objects into that array, and then we're going to call draw on each of those elements. So that's your assignment for today. Yeah? Questions? Okay. Anyone else with questions? Okay, I'll save this and I'll publish it right away in case you need to look at it again. So hang on.